Dear learners, for this course on control engineering, in this final module, that is in module 5, we were discussing on bode plot, that is stability analysis using bode plot. So far we have solved 5 numerical problems on stability analysis using bode plot. Continuing our discussion, the problem number 6 on stability analysis using bode plot states that sketch the bode plot for the transfer function g of s is equal to k s square divided by 1 plus 0.2s into 1 plus 0.02s. Determine the value of k for the gain crossover frequency to be 5 radians per second. If you carefully observe the problem given itself is in standard time constant form. That is, the simple poles what he has specified is in the form of 1 plus ts. And we have two zeros at origin. We don't have simple zeros or complex zeros, and we have two simple poles. So therefore, it seems to be we are going to get positive slopes for this problem because we have two zeros at origin. And also, he is asking us to find the value of k when the gain crossover frequency is to be 5 radians per second. Let us solve this problem. If we move for solution, as usual in step 1, obtain the standard time constant form of the given problem. That is, to obtain standard time constant form. Obtain the standard time constant form of the given problem. The given problem itself is in standard time constant form. No need to worry. So therefore, write it as it is. So given problem itself is in standard time constant form. No change is required. 1 plus 0.02. Yes. Right. Now move ahead for step 2. In step 2, we are going to discuss about the factors, that is discussion of various factors. Coming for the first one, that is k. Factor k itself is unknown here. Therefore, we cannot shift the magnitude plot because the shift is given by k, that is 20 log 10 k. Here k itself is unknown. We want to calculate the value of k, and k is unknown for us. K is unknown for us. Next, moving for the second one, that is s square. S square is called as two zeros at origin. We have two zeros at origin. For this, we know that the straight line slope, with slope for zeros, it is plus 20 cross m, correct? Here the value of m is 2. So therefore, plus 20 into 2 is how much? Plus 40. The slope will be plus 40 decibels per decade. Plus 40 decibels per decade. The general formula is plus 20 into m, where m is power of s. Here s power is 2. So therefore, plus 20 into 2 is plus 40, which intersects 0 dB at what? 1 radian per second. This you people already know. 0 dB at 1 radians per second. Got it? Next, move for third one. That is, we have simple pole, which is 1 divided by 1 plus 0.2s. 1 divided by 1 plus 0.2s. This is simple pole. Now for simple pole, it is a straight line with slope. For simple pole, the slope is minus 20 decibels per decade. This we have already discussed. Now, what is the corner frequency? At omega c greater than or equal to. So this is of the form 1 plus ts. Hence, the time period is known, the 0.2 seconds. Hence, omega c is 1 by t, which is 1 by 0.2, which is nothing but 5 radians per second. So greater than 5 radians per second. Next, move for the fourth term, that is another simple pole, that is 1 plus 0.02 s. 0.02 s. This is another simple pole what we have. So for which the time is given as 0.02 seconds. Hence the frequency is 1 by t, which is equal to 50 radians per second. Hence it is also a straight line with slope. Straight line with slope of minus 20 decibels per decade at frequency greater than or equal to 50 radians per second. So thereby we have discussed all the factors given for us. The factor k is unknown for us. Coming for two zeros, the slope of two zeros is plus 40 decibels per decade. Then we have simple pole with slope minus 20 decibels per decade, and we have another simple pole with minus 20 decibels per decade, and we know the frequencies. So hence I can go for resultant slope table. So move for resultant slope table. If I go for resultant slope table, if I go for resultant slope table, first one is factors, then we have frequency range, and finally we have resultant slope. Resultant slope in decibels per decade. We have totally 4 factors. Factor k is not known for us, leave it. We have 2 zeros. Their frequency range is greater than 0, less than 5 radians per second, and their resultant slope is plus 40 decibels per decade. And then we have simple pole, that is 0.2 s inverse. Inverse is because it is 1 by 1 plus 0.2 s, and its frequency range is 5 to 50. Its frequency range is 5 to 50 radians per second. Contribution is minus 20. So therefore plus 40 minus 20 gives us plus 20. Plus 40 minus 20 is the contribution. Plus 40 minus 20 is plus 20. Next, move for the last one, that is 1 plus 0.02 s inverse. Now what is the range? The range is 50 to infinity. 50 to infinity. Its contribution is also minus 20. Therefore plus 20 minus 20 will be 0 decibels per decade. So if you carefully observe, this problem is completely different from the problems so far what we have solved. So far the problems what we have solved has negative slopes, whereas this problem has positive slopes. Plus 40 decibels per decade, plus 20 decibels per decade, and 0 decibels per decade. Using which I can go for magnitude plot. But before that, he is asking us to sketch the bode plot, hence I should know phase angle plot also. Even though the k does not have any effect on phase angle, and we are going to determine k, if I won't use phase angle also I can solve the problem. That is correct, I agree. But since he is asking to construct the bode plot, I should go for phase angle plot also. So let me represent the phase angle plot also. That is in step 3. In step 3, I will go for phase angle calculations. Phase angle. Now first let me get the equation. I can get the equation by replacing s by j omega. So therefore replace s by j omega. I get the equation as k times j omega into j omega. This is how we should write it. J omega square should be written like this. Then only we can find what is the angle. Divided by 1 plus j times 0.2 omega into 1 plus j times 0.02 omega. And so what is the formula for phi? Phi is equal to, k does not have any effect on phase angle plot, whereas zeros at origin will give plus 90, so therefore it is plus 180 degree. These are in denominator, hence use minus sign. Tan inverse of imaginary part by real part. Imaginary part is 0.2 omega, whereas real part is 1. Again minus tan inverse of imaginary part is 0.02 omega, real part is 1. Clear? So I got equation for phase angle plot. Now no need to worry about the phase crossover frequency, which is not at all required for us. I don't want any phase crossover frequency because I am going to determine the value of k by using gain crossover frequency of 5 radians per second. So just you have to plot it in the bode attenuation curve, tabulate the results for omega and phi. Omega and phi. Tabulate the results. Let me take the values as 0.1, 0.2, 0.5 and 0.8, 1, 2, then 5, 8, 10, and similarly I will take it for 50. Now substitute and calculate. If I go for 0.1, it is plus 180 minus tan inverse of 0.2 into 0.1 minus tan inverse of 0.02 into 0.1. I will get the phase angle as plus 179 degrees. Plus 179 degrees. So similarly you compute all the values. Go for 0.2. So if I go for 0.2 radians per second, I will get the answer as 177 degrees. Similarly find all the values. For 0.5, for 50 I got it as plus 51 degrees. So if you carefully observe, all the angles are positive for us. So for positive angles we have not yet drawn bode attenuation curve. I will teach you how to draw for positive slopes and also for positive phase angles. Now if I go for step 4, that is plotting bode attenuation curve, using which I can calculate the value of k for the hint given as gain crossover frequency to be 5 radians per second. Taking the gain crossover frequency as 5 radians per second, I should find what is the value of k. Come, let us go for step number 4. Moving ahead for step number 4, I want to draw bode plot for our problem number 6, wherein which I want to find the value of k for gain crossover frequency to be 5 radians per second. Correct? So now if you observe, the maximum slope I require is plus 40. Very, very important. It is positive 40. I require positive slopes for this problem. So therefore, I'll start from, let me say I'll start from 40 itself. 40, 20, 0, minus 20, minus 40. So if I observe, it is varying from 0 to 5. So 0 to 5 radians per second will be here, and from 5 to 50. So I require more space to construct it. So therefore what I will do, I'll start the problem from 60. I'll start the problem from 60 because I want more space to construct, because since we have positive slopes, the line will move upwards. So I want more space above 0, hence I'll start from 60, 40, 20. I'll take this as 0 and this as minus 20, minus 40. That is enough, because minus 40 will give us plus 40 slope. Why I started from 60? Because I want more space. And now coming for angles, if I look at the angles are all positive. They are all positive. Therefore, I will start the angles from plus 180 degree. Plus 180, subtract 30 from it, it will become plus 150 degrees, subtract 30, plus 120 degrees, subtract 30, plus 90, plus 60, plus 30 degrees. Now from here, so this is the reference. From here to here, I am using it for magnitude plot in decibels. Magnitude in decibels till this point, and from there to bottom I am using it for phase angle in degrees. Phase angle plot in degrees. Now for frequency, since I have 550 50, no need to worry, let me go with as usual scale 0.1, 10 to the power of 0, 10, 100 and 1000. Let me go for as usual scale. Now I want a reference. The reference for magnitude plot is already known for us, that is 0 decibels is the reference for us. Let me have 0 decibels. And for phase angle plot it is minus 180. We don't have minus 180 for this problem. No need to worry, don't do anything. Now lay down the phase angle plot for which I want the slopes. Since I want positive slopes, use negative values. So therefore connect minus 120 to 0 decibels at 1 radians. Connect it. So this will give us plus 20 slope. This will give us plus 20 decibels per decade line. Similarly connect minus 40 to 0 decibels at 1 radians per second. Connected. So these two gave us the positive slopes, that is, this is nothing but plus 40 decibels per decade, and this is nothing but plus 20 decibels per decade. Now if you observe, we have plus 40 decibels per decade from 0 to 5 radians per second. So therefore plus 40 is this one, 0 to 5 radians per second. So continue it till 5 radians per second. Where is 5 radians per second? This is 1, 2, 3, 4 and 5. 5 is here. You can see here 5 is here. So till here I should continue. I'll leave some space so that you won't get confused that I continued the line itself till 5 radians per second. Next is what? Plus 20 from 5 to 50. So draw a parallel line to 20 decibels per decade, plus 20 decibels per decade from the end point, that is 5 radians per second, for plus 20 decibels per decade. This is plus 20 decibels per decade line. Draw parallel line. So this should move up to 50, 50. So this is 50. Draw till 50. Then from 50 onwards, it is horizontal line, 0 decibels per decade. It is horizontal line. Draw horizontal line. Done. So this completes the magnitude plot for this problem. See, it is completely different from the previous problems what we have solved. This should start from 0, to avoid confusion that I initially generated the minus 40 decibels per decade line. I have leave some space and not overlapped the magnitude plot properly, so that you will understand it properly. Now you lay down the angles. Coming for angles, we have at 0.1 plus 179. Next at 0.2 plus 177, plus 177 at 0.2, at 0.2 177, minus 6 will be 174, 177 is almost there itself. For 5 it is minus 174, for 5 it is minus 174. and for 1 it is plus 168, and for 2 it is plus 156, for 2 it is plus 156, for 3 it is plus 146, for 3 it is plus 146, and for 5 it is plus 129, for 5 it is plus 129, for 10 105, for 10 105, 96 102 105, and for 20 it is 82, for 20 it is 82, for 30 it is 68 degrees, for 30 it is 68 degrees, and for 50 it is 51 degrees, 54, 51. Now draw smooth curve. This will give us phase angle plot. So I got the phase angle plot also. Done. Now what he says? He says that find the value of k for which omega gc is 5 radians per second. Now take omega gc as 5 radians per second. Choose omega gc as 5 radians per second given in the question. Where is 5 radians per second? This is 5 radians per second, correct? So take it as omega gc. Omega gc as 5 radians per second. For omega gc to be 5 radians per second, what is the value of k is the question he is asking us. So I have taken omega gain crossover frequency as 5 radians per second. So if gain crossover frequency to be 5 radians per second, then entire plot should shift here, because at frequency is equal to 5 radians per second, the magnitude should be 0 decibels. That is what the gain crossover frequency means. The frequency at which the magnitude is 0 decibels is called gain crossover frequency. So therefore this is the shift I require. So this was the shift I required. In order to obtain this shift, how much I should move is the question. Now if I measure from here till here, the shift required is from A to B. Shift required is from A to B in the negative direction. I should come down. Actually 20 log 10k shift is moving upward, but here the shift is not from bottom to top, it is from top to bottom. I should come down. So therefore it is negative shift. I require negative shift. How much is the negative shift? I am coming down. So negative shift is how much? 1, 2, 3, 4, 5, 6, 7 boxes. So each box is how much? 4 decibels. Totally I have 7 boxes. 7 into 4 is 28. Since I should come down, so this is equal to minus 28 decibels. This is equal to minus 28 decibels. So this you people already know, because each unit I am taking as 20 decibels, therefore each box is 4 decibels. Whereas in angles, each unit is 30 degrees, each box will give us 6 degrees. Now we found out that the shift required is minus 28 decibels. That is what we have with us is for omega gain crossover frequency is to be 5 radians per second. I want the entire magnitude plot to shift from A to B. So shift required is minus 28 decibels, because the shift required upwards are taken as positive, shift required downwards are negative. This we people already know, because gain margin downward is positive, upward is negative from the 0 decibel line. Now how the shift is obtained? The shift is given by the gain, right? That is 20 log 10k. 20 log 10k must be equal to minus 28. Hence the value of k for this problem is turning out to be how much? That is 20 log alpha x. Alpha is equal to minus 28. If I solve, I'll get the answer as 0.0398. 0.0398 is nearly equal to 0.04. 0.0398 can be written as 0.04. So the value of k for this problem is turning out to be 0.04. Whenever you press shift solve, you will get the previous answer. Kindly press equal to, it will calculate and give the actual answer. So we have solved the problem for the given problem. What is the given problem? Find the value of k for g of s is equal to ks square whole divided by 1 plus 0.2s 1 plus 0.02s at omega gain crossover frequency to be 5 radians per second. For the given problem, for omega gc to be 5 radians per second, the value of k obtained is 0.04. So here we have frequency. In radians per second. This is the complete solution of problem number 6, wherein which we have calculated the value of k for gain crossover frequency of 5 radians per second. That's all from this lecture. Thank you all.